Hello everyone. In this video, we're going to go over the concept of cost functions. Now, by definition, the total cost function actually gives us the minimum cost that we would need in order to produce a certain level of output. Of course, for that, we need to know what the prices of the inputs are, and we also need to know what the value of the output that is being produced is. So, given the prices of the inputs and given the output that needs to be produced, the cost function is actually nothing but the solution that comes from our cost minimization exercise. So it is the minimum cost that we would have to incur in order to produce a certain level of output Q, given the input prices V and W. And the cost function is written in this manner. C is a function of three parameters, V, W, and Q, and all three are exogenous here. We know that V and W are prices of labor and capital and labor in the market, and the firm doesn't have any control over those prices, so we take that as exogenous. Q is the amount of output that we need to produce, so that is also given to us in exogenous. So this is how we write our total cost function. And from here, we have a couple more allied functions that we work with. This should be self-explanatory, but I'll walk you through that. We also have the average cost function, which is just the cost per unit of output. And we write this down as total cost divided by Q, or the amount of C divided by Q gives us our average cost. So this is just the cost per unit of output. And then we have our third function of interest to us, which is the marginal cost function, which tells us how much the cost increases at the margin for a marginal change in the output. So what's the change in costs for a unit increase in the output of production? So that's our marginal cost function. And as with all marginal functions we've been learning so far, MC is nothing but the derivative of the cost function with respect to Q. So MC is just the cost of one more unit, whereas average cost is the cost per unit of production. Okay. Now, notice that in all these three cases, whether we wrote down the total cost or the average cost or the marginal cost function, in all three scenarios, our costs depend on the level of the output Q, as well as the two prices V and W. Now let's look at some cost functions graphically and get acquainted with that. The first case is where we're dealing with a firm that has constant returns to scale. So with CRS, if it needs to produce double the amount of output, all that it needs to do is double its inputs. If it wants thrice the amount of output, it needs to triple its inputs, and so on. So in such cases, let's see how our cost functions, average and marginal cost functions, would look like. So with CRS, the total cost for one unit of output is written as look at the notation here. Cost of V, cost function depends on the price of capital, price of labor, and the amount of output is fixed at 1 unit. So that's why you see the 1 there. Now, this cost is actually V times K1 plus W times L1. So let's say we are using K1 and L1 units of inputs to produce 1 unit of output. And therefore, the cost of producing 1 unit of output is V times K1 plus W times L1. With CRS function, if I were to just produce M units of output, I just have to scale up my inputs also by the same factor M. So for M units of output, I will use M times the amount of inputs that I used earlier. So the cost now of producing M units of output is just VK1 times, so the price of capital times M units of K1 plus price of labor times M units of labor compared to what it was earlier. So if we just simplify this expression, turns out the cost of producing M units of output is just M times the cost of producing 1 unit of output, which makes sense because this is CRS production function. So once we've written down the total cost functions this way, look at the graph on the side. The top panel just shows you the total cost function. So as your output increases, the total cost increases in the same proportion as the output. So for example, suppose for 5 units of output initially, if it costs say 10 units of something, if I were to double my output to 10, my costs would now double by the same factor. If I were to increase my output by say 20 times, my costs would also go up by the same proportion of 20. Okay, sorry, this should be aligned like that. So therefore it will have a constant slope. So that's your total cost function. We can very easily see what the average and marginal costs would look like here. AC is average cost is just total cost divided by number of units of output. So if m units of output are being produced, I just have to take the total cost for m units and divide throughout by m. And the answer that I'll get is just C of VW and 1. The cost of producing 1 unit. Because for every additional unit, it's just going to be the same per unit cost because of CRS. If I want to compute marginal costs, all I have to do is just take a derivative of cost functions with respect to m. And when I do that, I end up getting the cost function as C of VW and 1 as well. So in this case, your whenever your total cost function is a linear line, the average and the marginal cost functions will just be a constant. They'll just be the per unit cost will equal the incremental cost of producing 1 more unit. So that's how things look in the CRS case. But now this is a very not a very realistic case. There are, it's very unrealistic to find a company that will have constant returns to scale throughout its the production process or the life of production. What is more realistic is that total cost functions will often start out by having so what you see here is, if you look at the top panel of your chart, see that the total cost function initially increases at a decreasing rate and then has a plateau and then starts increasing at an increasing rate. So you could envision a scenario where initially when production starts, every input that you're using is very productive. And maybe there's an entrepreneur who is managing all of these inputs. And once a certain minimum once a minimum set of inputs start coming into play, the entrepreneur's services are better utilized. So all the inputs start becoming productive. So when they're productive, you have increasing returns to your to your business. And so costs increase very slowly initially, because your inputs are quite productive. So 1 more unit of input will give you more output. So costs initially increase slowly. That's at this part of your chart. And then they have then there's a point where then there comes a scale of production, but some particular size of the firm where the entrepreneur is just able to optimally manage the inputs under them. And once you cross that threshold, it starts becoming really difficult to manage. Your inputs are no longer as productive as they used to be. So it starts becoming more expensive to have more inputs in order to produce more output. So when that scenario comes in, your costs start increasing more rapidly. So that's the part where the cost function takes a convex turn. Now this sort of a function, this sort of a graphical shape for the cost function is more realistic, and it's called a cubic shape. It's pretty much like an inverted, a mirror image of an S, if you can visualize it. So this is a more realistic scenario. Now the total costs begin rising rapidly after a certain point, after diminishing returns to inputs set in. Now the second panel just shows you how the corresponding MC and AC curves will look like. In the earlier case, when you had CRS, you saw that your cost function was a straight line. And when that happened, AC and MC were also just constants. Now, when your cost function is a cubic function, your AC and MC curves will now be parabolas. So in the next slide, I'll actually show you how to draw the AC and MC curves. Just a couple of points about how the MC and AC curves look like. Now, at the lowest point of my average cost curve, which is right there, my MC will cut through the AC curve. And that's just by design. At the lowest point of AC, MC and AC will be equal to each other. Now, how do you draw the MC and AC curves from your total cost function? I'll just very briefly show you that. I use a slightly different color to do this. Let me see. Okay, so first I'll just draw the marginal cost function. Marginal cost is just the slope of my cost function at every single point, right? So initially, these tangents that I draw on my cost functions are all, my cost function is increasing at a decreasing rate. So the slopes are all becoming flatter and flatter up to a certain point where the slope actually becomes, the tangent just becomes parallel to the line, to the x-axis. And then beyond the point, just notice that this is where that happens, at that level of output. And once you cross that threshold, your marginal cost starts climbing. So your marginal cost function is just all of these slopes, the slopes of all of these tangents. So initially, when your cost function increases at a decreasing rate, your MC is falling. And then it hits its lowest point. And then when your cost function starts becoming convex, its derivative starts having a positive slope. And that's how you get your MC curve. The AC curve, on the other hand, is just whenever you draw a line from the origin to any point on your cost function, the slope of that line is my average cost. So initially, the average cost is coming down. And then there's a certain level of output where the average cost just happens to be tangential. This chord from the origin happens to be tangential to my cost function itself. And then beyond that point, my average cost starts rising again. So this is what you see as your average cost falling initially. Okay, your average cost falls. And at its lowest point, the average cost, this chord that you draw from the origin is tangential to my cost curve. So it actually sits on top of this tangent that I draw at that point. So that's why you see your MC and AC will become equal at that point. And beyond that point, your average cost function will also start climbing. So that's just about the geometry of these curves. So I'm out of time in this video. So we'll talk about the mechanics behind cost functions and how they shift and so on in the subsequent video. So I'll see you there.